Welcome, everybody. This is the 60th YFTT, which means it's been 60 weeks since we've been doing this. Fantastic. I don't know. I'm very happy. I don't know who I'm saying fantastic to. It's really fantastic. Seems like a major accomplishment. But anyways, it's this week's topic is using Apache Spark with YugabyteDB. We're going to focus on large data sets in YugabyteDB being analyzed with Spark. Naitik is going to talk to us. Naitik, why don't you quickly introduce yourself and let's get underway.
Sure. So I'm Naitik Shah. I'm a part of the services and the customer success field team here at Yugabyte. And we engage with the customers at various stages of their deployments and help them get the best value out of YugabyteDB. So without further ado, I'll just start sharing. I guess I'm already sharing. Is my screen visible?
Yes, it is. Yes, I think. Thank you. And maybe you want to go into slideshow mode or.
Yes.
Yep.
So today's topic of discussion is using Apache Spark with YugabyteDB. And here's the agenda, right? So we'll start by discussing Apache Spark use cases and its software layers. Then we'll cover the Yugabyte and Spark integration. We'll go through some of the features of the Yugabyte Spark YCQL connector, followed by a couple of demos. First demo is mainly for a stream processing application with IoT sensor event streaming, data processing using Spark, and Yugabyte as the destination for persistent storage. The second demo that we have here is an ETL demo where we'll demonstrate the data that is being read out of YugabyteDB as a source, perform some data transformation, and then write it to a separate table within YugabyteDB. Right.
Fantastic.
So Apache Spark, right? What is Apache Spark in the first place? So it's an open source distributed computing system that is designed to process large amounts of data sets in a distributed way, right? So there are multiple machines doing this work. Not going to spend too much time on just giving an introduction of the Spark here. It is essentially an in-memory compute engine, right? So it allows you to get data from any source database like YugabyteDB, or even files, and perform analysis on the data set and then write the data back into the persistent store, which again can be YugabyteDB, and we'll see that in a moment, which can serve your transactional OLTP workloads, or even some of the web APIs, right? To say. So some of the benefits of Spark here, it's very fast, easy to use, and one of the primary benefits of Spark is its ability to handle large data sets, right? So one obvious thing to note here is both YugabyteDB and Spark are distributed in nature, right? So we'll get into the details in the upcoming slides there. But before we go there, we'll quickly talk about some of the use cases where Spark would be used. So one is the analytics use case. And we can take a classic retail example. Suppose a retail company wants to analyze the customer purchase data to gain insights, right, into the customer behaviors and preferences. Now, to analyze the data, they would use Spark to perform a series of transformations and calculations. For example, they could use Spark SQL to perform join transaction data with the customer demographic data, and then use the Spark's machine learning library, right, to create a model which predicts how the customer is going to shop in future, right, for example. And all of this large data set, that is there, which includes the purchase data, demographics, etc. It can all be stored in YugabyteDB for the application APIs and other access patterns. So that's about the analytics use case. Now the other is the stream processing use case. So let's take an example of a financial services company, right, that would like to monitor some of the transactions that are happening in real time and perform fraud detection, right, for example. So there are continuous streams of transactional data that's coming in from various sources like credit card transactions, wire transfers, ATM withdrawals, etc. Right? So now all of these could be pretty heavy volume of transactions, right? And they can all be handled very well with YugabyteDB. A lot of our customers are already doing this in production. And in order to process the data in real time, we could use, let's say, Spark's streaming module, right? And fraud detection has to be done real time. Like we can't wait until the transaction is complete per se. So it has to be really fast in memory, and we can perform a series of transformations and calculations on the data set, such as flagging transaction beyond a certain amount, or if a transaction, for example, happens beyond or outside of the business hours. So those can be flagged for fraud detection, right? For example, data pipelines and many more examples, right? So we can talk about a ton of use cases here, but just to give a very high level overview of the data pipeline use case, that would be consisting of data ingestion at a very high velocity and large volume, transform the data, store it in a centralized database like YugabyteDB, and the pipeline would then, again, consist of additional analytics or analysis on the same, right? So this would be basically a traditional Lambda-based architecture, right? And talk about like the speed, which is basically the real-time versus the batch layer. And this is, we can talk about a lot of use cases, but I would like to go further in just talking about, just the Spark ecosystem. So there are two components. One is the Spark core and the set of libraries. So Spark's generalized, execution model it supports like a variety of applications and languages, right? So that includes the Spark's core API, which has, Java, Scala, Python support. The data frames and the SQL part is purely for the Spark developers. Streaming is, again, event streaming, like what we are going to talk about for YCQL specifically. And this would include, for example, time series data set, right? So where you have like a messaging system like Kafka, and then the processing is done at the Spark layer. So we'll talk about that example in a moment here. And then ML is, let's say you have the data already sitting in YugabyteDB, right? And you want to start using machine learning. You can use some of the Spark ML libraries to build models on top of it. And you could store, again, the resulting models into YugabyteDB as well. So that's a high level of the Spark ecosystem. Now, here's the main part, right, where we have the integration with Yugabyte and Spark. Now, short story is wherever there is Spark, there's going to be Yugabyte, right? So if you have a Spark cluster, you will be able to connect to Yugabyte using either the YSQL or the YCQL query layer APIs. Now, we offer Spark integration for both of these, and for SQL, which is our distributed SQL API, we have the Yugabyte JDBC driver that is available to connect to the Spark app. And then for YCQL, which is our semi-relational language API, we have the Yugabyte Spark YCQL connector, right? And in the diagram here, we have the Spark driver in the application trying to connect to the Spark master. And then, there are Spark applications that run as independent sets of processes on the cluster, right? So then the Spark master would be able to divide that further into each worker node, or basically a Spark executor node. And then the executor connects, to the database, gets the data set, processes, and then sends it back to the driver, right? So this is a high level workflow of the Yugabyte and Spark integration per se. Now, We have further documentation. We have a ton of examples as well, right? For how you would interact using Java or Scala, and it's all there on our official documentation page. You can go and take a look. This is the link here. So I want to talk, since we are talking about the drivers, both Spark and YugabyteDB are distributed in terms of the architecture. And this is a good time, because then Spark, when interacting typically with a monolithic database, it's different from how it would interact with YugabyteDB, right? And you would see that in the diagram here. So for a monolithic database, for example, Spark would typically connect to the database using, let's say, a JDBC or a ODBC driver, and perform SQL queries basically to fetch the required data set. Now, the performance of such queries can be suboptimal, right? Because you're particularly dealing with a large complex data set, but then there's a single database that you're depending on to process and get you the data set. So unlike a monolithic database, you see for Yugabyte cluster, as we know, the data would be sharded across multiple partitions or multiple tablets across the Yugabyte cluster. And while the driver is interacting with Yugabyte, it can take that advantage, of the distributed architecture and the same queries and the data set can be pulled very efficiently, right? So that's that. As far as just the high-level features of the Yugabyte Spark CQL connector, we just want to go through some of these, and we're going to focus, or our scope of today's presentation is just the YCQL connector. So the Yugabyte Spark CQL connector is cluster and topology aware, right? So it already knows before it even connects to the cluster, saying, these are my partition keys, these are the tokens, right? So it would send queries onto specific partition ranges to the nodes which are responsible to hold that tablet, right? So that's what's meant by cluster and partition aware. The other feature that we have is push down optimization, right? So that's basically inbuilt within the Spark Yugabyte connector, which allows the push down of the SQL queries, right, onto the Yugabyte for execution. So this is very important and efficient because it would reduce the amount of data that needs to be fetched from the database, right? So if you don't need the entire data set, if you just need like a set of primary keys or specific columns, right, you could do that and you would get that push down optimization, not pulling the entire data set out, but just pulling out specific columns, right, out of the database.
And just to mention here, right, it should be possible to use like a secondary index or some of those features also for efficient access, right? Because when you're pushing down the query, it is backed by an index which is quite unique to YCQL, right? Like you will get the advantage. Is that right?
That is correct. Yes.
Okay, got it. Okay, let's keep going.
That's even better, because that's an additional enhancement, right, that the database would provide in terms of like the access pattern and efficiency. That so in addition to what the driver would provide us, right, with the push down optimization on the Spark side. So yep, totally, that'll be even more efficient. So for the other feature that we have is basically native JSON-B support. And this is a very, very unique feature for this Yugabyte Spark connector. And what we could do is, in Yugabyte, we support, even for YCQL, we do support the JSON-B data type for columns, right? So this is, like I said, it's a very unique feature because JSON-B values are processed using the Spark JSON functions, like the getJSON object, and you can use that to select a specific attribute within the JSON object. The other part, of course, and you can also perform filtering on that JSON. You can have certain conditions, etc. The other interesting thing is the JSON upsert feature that we would have. So which means that you don't need to, when you insert a specific column into the JSON object that we have, you don't need to overwrite, the existing columns, right? So the existing column stays as is, and you could still add a new column in that existing JSON object that you have, without overwriting or without needing to overwrite the existing fields, right? So that's one of the added features, and you would get all the benefits and efficiency of the JSON-B that we provide within Yugabyte, right? From performance standpoint. Now, some of the best practices, of course, that we have seen, for our customers, right? And we have several customers using Spark and YugabyteDB in their production deployments as of today. A couple of large scale ones that I can just call out. One is an automobile company which has about 650,000 write operations per second, and this was a Cassandra to Yugabyte migration originally, where we were able to move more than 360 terabytes of data. And during the migration, it's interesting that the peak write operations that we reached was about 2 million write operations, right? So which is huge. So that's the scale that we are talking about when we look at the YCQL connector, right? And there's another large customer as well, which is having or using Spark and Yugabyte in production for about 15 of their applications. And they have close to 1 billion write operations per day, right? So that comes down to anywhere between 10,000 to 15,000 operations per second. And all of those are served with minimal latency, right? So those are like
awesome.
fast.
That's great. Fantastic. Cool. So yeah, let's go to the demo soon. Let's do it.
Yep. So yeah, I'll just go over the I think this is the part of the demo. So I want to explain how or which components we would have, right? For this is a stream processing demo. So we would have this is an IoT based use case that we are trying to portray here, right? So you would have certain IoT devices sending out the sensor data, and then we have a messaging system, which is Kafka. It's gonna basically consume those events, and then those are all going to be processed within the stream processing, which is Apache Spark. And then after performing the processing transformations, we're going to load this into the persistent storage, which is our YugabyteDB cluster. Right. So this is the high level flow. In our case, we are going to use NoSQL Bench, which is one of the performance testing tools that we have been using for mainly testing Cassandra-based workloads. So we are going to use that to generate the data set of sensor data, and then the rest of the components are the same. But we are going to have, of course, a single node instance of Kafka, a single instance, local instance of Spark running, and then a single YugabyteDB instance as well, a Docker instance. So let's go ahead and get to the demo. All right, so the first component here is the NoSQL bench. And I would like to get this. I want to show basically how the data would look like just by performing a standard output or even within the Kafka producer, right? So I don't want to get into the details of the NoSQL bench here, but essentially what we are trying to do is we are trying to use this as a Kafka producer, right? So it'll start to create or generate synthetic data based on our YAML definition that we have for NoSQL bench. And then it's going to use the data to send it to as a Kafka producer. This is the YAML file that we have. And then this is, of course, localhost, and then cycles is basically I'm telling it to generate 5 events, right, in this case. So when we do this, I just want to show the Spark or the Kafka as well. So I have a local Kafka standalone instance. I have Zookeeper running here, and then also the Kafka server, right? So both of these are running locally.
Got it. So now you have a setup that is going to generate data and put it into Kafka, right? That's the first leg of the diagram that you showed, right?
Yes.
And then Kafka will push to Spark, and then Spark will push to
correct. Yep.
Yugabyte. Yeah, got it.
Yep. So, so I'm just gonna use the topic. So Kafka topic that we're gonna use here is IoT input, and I'm just gonna say I'm gonna start consuming just for testing purposes that everything is looking fine. So I'm gonna start consuming. There's nothing that's coming in right now from which Kafka can consume unless and until I do this, right? So it's a basically I generated 5 of those records, and then we see those 5 random records getting generated here. So now this is basically a data set, IoT based data set. So we have the name of a city, which is like a device name that we have here, and then the rest of the comma separated values that you see here are temperature, humidity, and pressure, right? So we are assuming that this is an IoT based use case where we are just trying to get temperature, humidity, and pressure for each of these locations, right? So in an ideal scenario, you would have hundreds or thousands of IoT devices, right, in a single location. But for simplicity, we are just trying to portray here just a specific set of devices, right? So we have about 5 device IDs or device names, which we are tagging for with different locations, right? So that's good. I have a script which is gonna start generating just the cyclic loop of it's going to start or keep generating some of the synthetic data that we want from NoSQL bench. But before I do that, I just want to quickly show. So I have Spark running as well. So there's a Spark master and a Spark worker node running locally. So I have this. I have Spark master, and if you see a live workers 1 here, right? So that's all I have. And then the application itself, I'm going to start navigate to my application here, and all right. So I'm going to use a Spark submit for this application, and it's going to start start to basically write to Yugabyte, right? So in the meantime, before we let's take a look at the Yugabyte cluster as well, right? So I have a local Docker instance running, and I'm just going to go to the key space, which is YFTT, and then tables. I have a couple of tables. I'm going to look for sensor data right now, it has 0 records. I can just do a quick describe of sensor data as well, right? So how it's going to store is UUID and then the device temperature, humidity, and pressure, right? So UUID is the primary key here. All right, so everything looks ready. So we can start generating the records here using our user script, right? So all it's going to do is it's going to start generating a few of those records, and we would be able to see those within our Kafka producer as well. as you would see, there's a ton of events coming up. And if you see on the app side, it has started writing to Yugabyte here, right? So every 5 seconds is the interval that we keep within the app to check for all the events, right, within the Kafka stream. And then the Spark streaming is gonna perform certain aggregations and then group those for a specific timestamp. And we are generating timestamp based UUIDs. So for each of those UUIDs, it's gonna write that data into Yugabyte. And now we can even check our data set, right? So we have about 36 rows here. As you would see, for a specific UUID, we have a device name or the tag of the device, and then of course temperature, humidity, and pressure values. So again, I mean, this
Pretty awesome.
multiple entries. Yeah, for example, for Los Angeles, right? We would see multiple entries, but then those are different UUIDs, right? So that way we know that this is from a different timestamp. I mean, we can have a timestamp as well. In a real world use case, like I said, we would have several IoT devices with their own station IDs or sensor IDs of their own, right? So there's like a end-to-end mapping, and there would be like tons of thousands of events. So, but here it's just for simplicity. Now, this is all good, and I think as you would see, it has stopped writing. So let's see how many records have we got. Yeah, we've got about 70. So with this, I think it's good just to perform certain aggregation, right? So we'll go to the next step of the demo, which is so we are able to demonstrate this entire workflow or the stream processing, right? In terms of NoSQL bench, which is generating the data set, Kafka, which is message queue, Spark, which is doing the processing of the data set, and then we are writing it to Yugabyte. Now, the next part of the demo is the ETL, which is...
We've got about like 5 minutes, so maybe we should get to it quickly. Yeah.
Yep.
Go for it.
Sure. So ETL is nothing but, basically pulling the data out of Yugabyte, performing certain transformations, grouping, batch, aggregates, etc., and then writing the newer data set right into Yugabyte again. And then just wanted to call out, right? So we already have a Yugabyte blog and a presentation and a slide deck as well. This was for one of the workshops as a part of the DSS, which is our Distributed SQL Summit. And that was presented by Amey and V from the Yugabyte team. So go ahead, check this out, right? It's basically a walkthrough of the Spark application itself. So let's quickly go to the ETL demo as well. So with the ETL demo, what I'm going to do is I'm going to read the data set out of this sensor data table that we are seeing, which is about 70 records. And then I have a new table, which is average temperature, right? So all I want to do is basically I want average temperature for each of these locations, right? That's all I want. It's a very specific aggregation and grouping that I'm going to do. And I'm going to store that again into Yugabyte, but performing those aggregations and grouping within Spark, right? So that's what we are going to do here. Just going to make sure. Yeah, there's nothing right now. So, all right, again, this is a Spark submit app that I'm going to generate, and then we'll start to look at some of the things that it did, right? So the first thing that we have here is, just a demonstration of how we are able to select the data set, right? Limiting to 10 records from the censored data table. That's what this shows here. So we have the same exact data set that we see here on the right side for within YCQL SH, and then we are displaying that. We are displaying the entries for a specific location, right? So you can have certain queries where you can select for a specific device. And then that's what I have it here. Now, from the aggregation perspective, I want for all of the locations, want to take an average temperature and then write it to Yugabyte, right? So, and then it says, yeah, finished writing to awesome YugabyteDB. And then it should have written it here, right? So we see for each location, so we have total of 5 locations. It was able to average out the temperature events, right, that we have.
That's pretty cool. Yeah, really nice.
Yeah. So yeah, that's all about the demo.
Yeah, makes sense. I think now you can do things like if the temperature exceeds a certain number for a certain window of time, you can put it, and that becomes, yeah, you can actually act on it. Yeah, I can totally see how this is used.
Exactly. So yeah, if you can send alerts saying, if the temperature is beyond 80 degrees or 100 degrees, right, then notify the folks within this area, etc. Right. So yeah, absolutely. That's a good point. So from the real world standpoint, I mean, we can do a lot more. Like I said, the JSON B is a major feature that we have, right? It's a very unique feature, and that provides the flexibility of the schema that you would have in the database. So that just opens up so many possibilities, right, in terms of how you can query the data set and what you could do on top of it using Spark.
Awesome. Fantastic. Great. Thanks a lot, Naitik. This was really awesome. Very, very nice demo, especially given that whatever you showed is working at a pretty massive scale, right? Like millions of writes per second and, like 15 applications. So a variety of such different applications. So it's really, really cool to see. So thanks a lot. Once again, folks, if you have questions, please drop it into the LinkedIn comment box. You can also leave questions for us in our community Slack. Yugabyte.com/Slack. Just go to the YFTT channel. We'll be looking at it. So have a good day. See you guys, same place, same time next week. We'll have another topic. And thanks a lot once again, Naitik. Really, really awesome.
Thank you.